Welcome to another IronCAD video on Two Tall Toby's practice models. This is dated 8/8/24. This is a sheet metal mushroom bracket. So we'll design this on IronCAD sheet metal, and we know that the thickness of this is 8 millimeter and the inside bend radius is 10 millimeters. And we know some other things that we know that there's a sharp edge here that's at 178. The width is 132, and our bends are set back at 140. And we have this shape here that's got a angle on it at 60 degrees overall. So we'll go ahead and show you how to design this IronCAD, and we'll just use these information here for a lot of this as reference. I'll put it on the other screen, but you can have this if you like by grabbing that practice model. So what we're going to start off with is sheet metal, so you can access that in our our starters catalog, or you can go into our more catalog and select sheet metal. Either way, you get to this sheet metal components, and we're going to drag and drop that out. I have my systems in English, so these are all in English units, so just going to hit OK in that, and then I'll go into our part properties and set the values here. So in our case, we know the thickness, again, was 8 millimeters, and the inside bend radius is 10 millimeters, and we'll select OK to drive that. Next, we'll go ahead and set the overall size of this. So we know the width, again, was 132, and we know our starting point that we want to use is actually this sharp corner here before that angle, so that's 178 to set that. So that's our starting location. So this is our kind of our bounding box, if you will. So everything has to fit inside of here from our bend standpoint. So to do that, we're going to use our out bend. So we're going to drag and drop that onto an edge inside of there, and we can pull this up and set the value for this. So there's a couple ways to do this. One is just right click on this handle and set edit distance from point, and you can select any reference. In our case, it's the bottom edge here, and it's 66 millimeters from that. Let's see if it changes that. Sorry, I hit the key there on my keyboard. Sorry about that. So now we've got that set to 66. Next, we want to set the distance of this bend, which is going to be set back. In our case, it's going to be set by double clicking on the handle at 140 for that. Next, we want to do this relief. So you can build, a cutout and a blend on there. But in our case, we actually have bend reliefs on this thing. So what you can do is hit your tab key while you have a bend selected. It'll switch over to our other handles, which are the bend handles, which you can pull these bend segments in or select these to add a relief. In our case, we're going to right click on that and hit bend properties because we need to set the value for that. In our case, it's 10 millimeters, and we need to calculate this other value, which is actually the 132 minus 75, because they give you a dimension here. I'll show you this. They give you a dimension from the inside to inside. So we know this is going to be a 5 millimeter here. From this geometry, this cutout here, that's going to add the radius on there, then it's 75. So we'll just subtract those and get that value, divide it by 2, and subtract the 5, and that basically gives us 23.5 for where this edge is, and then the 5 millimeters will be added for the radius. So we'll go ahead and put that in there as 23.5. And in our case, again, don't worry about this. This is if you show formula. There's a formula behind here that's driving this geometry. But in our case, we're going to go ahead and select rounded in this case and hit OK. So that will build our geometry for us automatically. And now we can go and continue on our geometry. The next thing is we want to add a chamfer here. So you can use our chamfer tool, or we have a feature called vertex chamfer that you drag and drop on a vertex point, and then you can just use the handles to set the value. In our case, it's got a value of 45 in one direction, and in this opposite direction, this is 45. This one here is going to be 25. So we'll type in 25 for that to build that shape. Next, we're going to put our slot feature in here. We can drag our standard slot feature out, or you can scroll down. We have some shapes inside of here that have some additional properties. For example, this oboe round. We're just going to drag and drop out here, and the first thing I'm going to do is rotate this around. So I'm going to lock the tri-ball, grab this axis, and just kind of lay it that direction. So it's going in this direction. And then we can right click and go to tooling properties, and we can set the overall value for this guy. And in this case, it's going to be the 57 plus 25. So it's going to be the 82 for that, and then it's going to be 25 width. And we can hit OK. Next, we need to position this, and it's got a reference as 40 millimeters from this edge to the center point, and from this top edge to here is 13 millimeters. So what I'm going to do is turn the tri-ball on, hit the space bar, and I'm just essentially going to move it up to this point here, which gives us the center point and the top edge at the same time. Now I can just move this by hitting the space bar. I can move the whole shape up to this top corner point there. And now I can use my, what we call our plane handle. I'm just going to right click and move this down. And it's going to give us two directions here. So if we go ahead and hit move here, it's going to give us those values. It's kind of hard to see here. If you zoom in before that, it's going to give you the direction 1 and the direction 2. So our direction 1 in our case is going to be 40. In our second case is going to be 13. in that. We'll hit OK. And that should move us in those locations. So just to confirm on that, you can select this edge here, select your top edge, and you'll see that distance is 13 millimeters from there to there. So that will give you the value for that. Now that we have that shape created, we need to duplicate that onto the other side. So we'll just use our mirror feature command. So if we go to our home or to our feature commands, you can select on the mirror feature or select our part. And what we're going to mirror is this bend. We're going to select our slot feature and our cut feature here that we want to mirror. And our plane, in this case, is going to be the center point of this geometry, and hit OK. So now we have that to the other side as well. Okay. Next, we're going to drag another bend out here. Again, it has to be an out bend because it needs to be on this back edge here. So we'll just scroll back up here, get our out bend, and I'm going to drag and drop it right on that center point, because it's important to have on that center point, because what we need to do is set the width of this. And we know the overall width is 42. So what you can do is go into the IntelliShape properties, and there's this above and below. This gives you the total from that center point where you drop, what the distances are on to the left and the right. In our case, we want those to be 21 and 21, which gives you the total of 42 to get that centered there for you. Now, I mentioned we need to set the height for this before. We just right-clicked on this and set to the bottom edge. To set that, you can also double-click on these. This will bring up your stock bend height, and you have various settings in here. So if you want, a virtual sharp value inside of there, you can edit that distance. In our case, this needs to be 45 from that virtual sharp in our case. So we'll go ahead and set that. And we can use other geometry inside of here, standard geometry to add that arc to that. So let's go back to our shapes catalog or our starter catalog and drop a cylinder here. We'll just flip that the other direction. I'm going to snap align that there and grab our outside handles and snap align that there. So that way gives us our basic shape for that model. Next, we can go back. We can use our hole feature to do this, or our other feature. Either way can work on here. So we're drag and drop a cylinder on this. In this case, it's got a diameter of 20 on this guy. So we're typing 20 for that model for the hole. So that gives us our diameter hole. And now we need to add our reliefs to this. Again, in this case, this one actually gives us our information for us. So again, hit Tab key, select on your corner relief. You can right click, go to bend properties. In this case, it actually gives the information that we need. So we know this again is 10 for that value, and we know the depth in this case is going to be 33 for that model, because it actually gives you that information inside of there. Again, this is just modifying the formula, and we're going to go ahead and hit rounded for that, hit OK, and we can do the same thing for this side as well. So it's going to take both of those values and automatically add them. Okay, so now we have that geometry created for us there. The last thing we need to do is add this triangular shape here, and what we can do is go back to our sheet metal catalog, and we're going to add stock from this location. And we know the distance, the overall distance from this outside edge. Again, we can right click, edit distance from point, and we know this back point here needs to be 240. So that overall distance is 240 for that geometry, and now we can edit this cross section. And what we need to do is change these angles on this. So I'm just going to put some dimensions here to make sure that we maintain whatever height this is. And we're just going to leave this as a locked constraint here. And now we can just kind of pull these in. Either way, we just pull both of those in, and we can just type in the value. So it's going to be 60 inside of there. So we select on this guy. That's going to be 120 for that one. And we can select this one, and that's just going to be 60 there. So that will give us our dimension, overall dimension. If you want to see that, you can put a dimension from here to here to see that. It's going to give you the 60 value. I'm just going to leave that off. So now we've got that shape there. We can add the blend. We have a blend that's going to be here. We can add it in here, or we can do it with our blend feature just to show you this. We can select down to these edges here, and we know that it has a blend edge value of 15 millimeters for that. We'll go ahead and select this other one as well. Hit OK, and that will give us our shape. So that's our overall geometry for this model, and if you want to unfold that, you can unfold this. You can look at that model if you like, using our look at tool. Select that, there we go. And see that geometry there? That's your model in this case. And we can go ahead and refold that back up. In this case, the model, we'll go to our properties. We need to set the mass density for this guy at 7800 inside of there, and we'll tab out of that, and that should give us a value, let's make sure that's correct, of Oh, sorry, that value's not correct because I'm missing one last thing here. So sorry, this is a live video, so let me go ahead and update this. There is a hole here that needs to be added as well. So we'll go ahead and just drag and drop one of our features here, so we can just use custom profiles, another example of tool that we can use. The nice thing about the custom profiles, it adds these dimensions for it. So what we can do is just actually say the reference for this actually is this back edge. It doesn't matter which one. And then we can actually double click on that, and we know that hole is located at 200 from that back edge. There we go, 200 from that back edge, and it's got a diameter of 40 for that. There we go. So that will set that for us. Now we will have our exact geometry here when we center this. And now if I look at that, it should be 2382. That is correct. So that's what I was missing on the first one. So hopefully you guys caught that before I did. Anyways, that was the last thing that we needed to add there. If we want again, we can unfold that to get that updated flat pattern as well. But that's our model for the Too Tall Toby example. Hopefully you found this useful on how to use IronCAD sheet metal to use these reliefs on our bends and to use out bends to build this geometry. Thanks for watching.